Okay, hi, how are you guys? Okay, so we're still moving forward with our problem solving on linear algebra. So this problem that we're going to look at this point in time, it is a problem which is based on verifying one of the properties of the trace. You see that? So the trace. So recall that we define the trace as being represented as follows for the matrix, and it is defined as follows. For all k, it is just the sum of a k for a particular matrix such as A. That's what the trace really is. Now, the question that we want to prove is as follows. Given a square matrix A, which is an n by n, and another square matrix B, which is also an n by n, prove that the trace of A plus that of B is the same as saying the trace of A plus the trace of B. So how can we prove this result? We want to prove that the trace of the sum is the sum of the traces, as we can see in this problem. So how can we go about proving that this result is true? You see. So let's see how we can go about proving this. So how we prove this result is I'm going to take one of these sides and then prove that it's equivalent to the other side. So I'll take actually the right hand side. So the right hand side, it talks about trace of A plus the trace of B. You see that? So according to the definition of the trace, we know that this actually means that we are talking about the sum from k equals to 1 to n of A k plus the sum from k equals to 1 to n of B k. That's what it means according to the definition of the trace. But what we have now is we have two sigma signs which all count from the same in this and end to the same result. So we know according to the properties of the sigma notation that I can combine these to sit under one sigma notation to get this of AK k plus BKK, like that. You see. But if you can look now, what you have here is you will see that inside the brackets you have a sum of the diagonal elements of two matrices. You see that? So you are summing the diagonal elements of A and also the corresponding diagonal elements of P, which means this is just the same as just calculating the trace of A plus P. So which proves the result, and therefore done. You see. So if you like, also you can take the reverse side and then also use it to prove that same result again. Otherwise, there is nothing else that we can do for now. So the other property of the trace is so easy to solve, so I'll leave it to you guys to just try and see if you can prove it also using the same strategies. Otherwise, thank you for watching. Meet you also on our next problem. Bye.